PyBCN.org, and then we can set up the meetup. Okay. Right. Then we're gonna start with Alex's talk.
You want? Like was a light.
Okay.
So my name is Alex Vinyals, software engineer in the Hotels data team. This is the team that delivers all the data that reaches production. So when you search hotels, the data is this page comes from us. And I'm here to present you the process that also fills the images. So one of the challenges of being a meta search is unifying all the data. Because in order to get the cheapest price, it's in your interest to get many providers of data of hotels. So this is a search results page. If you look here, you see that for this hotel we have many providers. When you see a provider here, it means that we did an integration with them. An integration usually means that they give us access to their catalogs of hotels, and our job is that this hotel is searchable through the page. But this hotel is being provided maybe 20 times by different partners. So we want the hotel to appear once here. Usually what happens is this. In this case for a triangle. Imagine we have 3 partners and each of them gives you the data of this venue. But they are going to use different names, different addresses, different coordinates. So we make some magic, and at the end we have this venue arriving once at production with the best data that we find. If we do that for all the hotels that we find in the catalogs, we end up with the data release. So what about the images, right? Because if you find this hotel in the page, you probably will not book it. It has no images, it doesn't give you confidence. So images are really important for this product. So how do we make them reach production? It's a similar case as with the data. Partners give us images of each hotel that they have. So what usually happens is you get tons of similar images. And in a perfect world, if we have those images, we want to show it once. Otherwise, you will see always the same images. It doesn't give value to you. So this is how the images are seen on the web page. And if you click that, you get a gallery of images. And if you look closely, you will see some duplicated images there. I added an extra slide making a zoom for you. Yeah. This is really similar image. So we're going to see all the problems that we face trying to bring those images up there. With around 200 partners, almost 1 million hotels reach production. So we're going to process around 35 billion images. But we do something extra. We try to resize them. The reason we do that is because we want those images to be optimized for mobile devices. You don't want in the app to be scaling that image on the fly while the user is scrolling. This will be not a snappy, fluent app. So we scale them down, and when you scale down an image, maybe you want to also improve the contrast of that image so it looks better. We do many things, and we do, as I say, 40 configurations. Here you see in the web page how we use those scaled down images. I believe it's a 45 pixels scale. So I'm here to tell you about the tail of an image processing pipeline. But before that, I'm going to tell you the technology stack that we use. Starting with the database, we are proud Postgres user, but we are also on AWS. So we use the managed version of that, provided by Amazon using RDS service. The pipeline has some very well-defined steps, and we bring them together with queues. Again, we use the Amazon solution, simple queue service. You'll see more about that. And finally, the raw power, the instances. We use CentOS machines, and we auto-scale them up and down according to need. So this release is not running always. When we don't run the release, everything is scaled down. Now, as for the libraries, we have an API. This image release is consumed by the data release. So we need an interface to put data and get data out of the image release. only use the Django ORM. It's maybe surprising, but we have workers, and workers are on the Django apps. So we wanted, and workers are accessing the database as well. So we put a school algorithm there, and for the messaging we use combo. Probably you use salary at some point. If you use salary, you're using combo, because combo and salary are made by the same guys. So basically we have a consistent interface, and if tomorrow we want to change from SQS to Rabbit, nothing changes on our side. Boto, if you do Amazon stuff, you will be using Boto. This is de facto. And Pillow for image processing. It's a fork of a library named Pill. It's actively maintained, and it's really nice. You can see. We use Python 2.7. I hope you're not disappointed by that. But it's a conscious decision. We are not using it because, yes, we like old stuff. So, image release integrates with the legacy system, so it makes sense for us to make sure we write compatible things if we ever merge code. So, the pipeline has a very clear separation. We have an asynchronous step and a synchronized steps. So the asynchronous steps can run continuously, and the only purpose of those steps is to process as much as we can before reaching the data release stage. Then the synchronized steps run together with the data release. So the data release will say, hey, these are the hotels that go to production. Give me all the images for those hotels. Because we have hotels that don't reach production, so it doesn't make sense to generate images for hotels that don't reach production. So we will start with the triggering. How do we start processing images in the system? We have an external worker that goes through the catalogs, the partner catalogs. It starts retrieving URLs from them, and it says, oh, from the previous release in this one, there have been many changes. Those URLs are new. Those URLs have been updated, or those URLs disappeared, and the images should not be there anymore. This diff is computed and is sent to the API, the image release. And the image release timestamps everything and stores it in the database. That's what it looks like. We get the URL, we give an identifier to the image, so the image progresses through the pipeline and we keep track of it. And then we get these pair of IDs, so that we can trace back this image to which accommodation of which partner it belongs. And so we go directly to downloading already. The API, when it receives those payloads, it generates messages that go to the downloader queue, and the worker starts consuming them. When it gets a payload, it hits the partner CDN, downloads the image, and stores the image into our system. This is the S3 bucket that you see here, meaning that if tomorrow the partner is not available or he deletes his data, we still can use the same inputs and run the release again. And obviously, the status of the images are updated into the database. Did we fail downloading the image? Or maybe we got the compression bomb. Who knows? So, this is what the code looks like, simplified, and it's not really the real code, but we got the payload. This is the cute image thing. It has attributes. The API puts them there. So we hit the CDN, we get the response, the binary content of the image, and we create a new key into the bucket. And we fill the contents of that key. After that, we try to do some filtering. We load an image with PIL. Remember to grab your blob of data with bytes.io, because you need to read from that. And then we ask, should I filter that image? We use some basic filtering using the dimensions. And if it doesn't get filtered, then it goes to the next step, which is fingerprinting. Notice here that we use a decorator, reliable callback. What does it mean? So imagine you have a worker and you're trying to process a million messages. And one of those messages is killing your worker, or when the handler runs, an exception that you don't handle kills it, you stop processing messages. But that's not what you want. You want to be continuously processing payloads. So we try catch the functional execution here, and we catch anything that is not handled, and the worker doesn't die. We also do another thing, which is setting a warning to be an exception. Pillow is a nice library, and he tries to protect you from the compression bumps. The compression bump is that you get an image, you try to decompress it, and memory starts exploding. So you think this doesn't happen, but it happens. Partners give us the compression bumps. So what a worker looks like. We create a consumer, and we pass that consumer a handler, and all the messages that come from that backend are going to be mapped to the handler. Then we just call the listen method, worker picks up, we create a connection, consumer, and then we start getting events from the event loop. Now when a message pops in, Combo is going to map that message to a callback. The callback is going to run whatever you tell him to run, and if nothing fails, it will acknowledge the message, and so no other worker will process that message. And we go to fingerprinting. What is fingerprinting? Well, fingerprinter basically just gets the message from the queue and downloads that image that we just put in our system. Again, updates status in the database. The question is, are those images the same for you? They're the same. Because the computer says no. You do the ND5 of that, and it's different. You look at the pixels and they are different. But if you go to the gallery and you see those images there, it's obvious that they are the same. You don't want to see them 3 times. So yes, they are the same. And so we are going to see why we do that. What we do is we compute a hash of that image, of the contents of that image, such that hashes of similar images give you a similar hash. Now, we do something slightly different. We do the cropped hash. We'll see why. But first, just make sure that we use image hash for that. It's a library that gives you 3 hashes already. We use the differential hash. You get perceptual hash and other stuff. But yeah, we use the differential hash. And what does a cropped hash do? It goes to an image and it does a sequence of croppings. 10% crop, 20% crop, 30, 40, 50. And the reason we do that is because partners usually give you images, the same image, but one partner goes and crops the image by some amount. And you want to be able to just to later on in the future say, hey, those are similar, I don't want them to be production. That's it there. That's it, the same algorithm. So we run the hashes, we do the crops, and run the hashes on those crops, and we store all those hashes in the database. And we go to the duplication. The asynchronous steps finish here. So what is the duplication? This worker does the work after the data release. The data release triggers the input to the API, which basically he says, those are the autos that reach production, those are the groups. The API will generate payloads, the duplicator will take them and start doing the work. And then, if it's needed, only if it's needed, the group will continue the pipeline. So we are trying to be differential here. If a release happens and an auto stays the same, it's provided by the same providers, our images haven't been updated, you simply don't do anything. Nothing changed. This is the visual explanation. The yellow cube is messages arriving in. Here we see how we reach almost 1 million groups. And then you see that they start decreasing. Means that there are workers getting those messages, doing something with them. And here in blue you see the next step. Not all the messages go to the next step. We try to avoid computing images if nothing changes between a release. This is what the groups look like in our system. Basically it's a group and we say the membership of that group. The membership are the page of IDs of each provider, each accommodation of each provider. So we have this, and we say, give me all the images for that group that reach production. We get them, and the question now is, find the groups of similar images. If you're a human, you go here and you say, I have 2 groups. And the conclusion is, this group from production, 1 to 3, has those 2 image groups made by those images. The code looks like that. You get all the images, and you start with 2 groups. Then you bootstrap a group, the first image that you find. And then you start comparing that image against the rest of the pool of images to be compared. Then you ask the question, is this the same picture? If it is, you just expand the group and remove that image from the pool. Eventually, the thing will finish and you will get the result. So what is this same picture doing? It's basically accepting all the hashes that we computed for one image and for the other. And then it computes the Hamming distance. So if this Hamming distance is below a threshold, we say yes, they're really similar. We are using, I believe, a threshold of 7 bits. This can be tuned. And so the question comes, how do you tune that step? How do you make sure that tomorrow you don't get one image per auto because you are merging everything together? Or maybe you start getting tons of duplicates because you're too strict and you don't merge the groups together. So you need a guarantee that this doesn't break and that this behaves as you expect. So what you do is you build a corpus. You select, you make a variety, a big selection of images, and you go through them manually. And you create groups. Manually you say, me as a human, I say that those are the same. So you establish the truth, and then you run the automatic algorithm, and you compare those results against what you say as a human. And then you can extract metrics from that, because you know what the truth is. Those metrics are here. This is integrated with the continuous delivery pipeline. So every change we made in the code has an impact here, but if it touches the duplication. So our job is to make sure that when we are happy with those results, we stop tuning the system. And later on, we try to enforce that maybe tomorrow we don't have 50% duplicates, or the completeness decreases to 30%, which will be dramatic. And we go to prioritizing already. So we have the groups. Later on.
How often do you tune the algorithm? How often do you manually go and look for images to...
So we tune it at the beginning, and when we were happy with that, yes, it was like focusing just on the tuning. When we are happy with those results, we just stop touching it.
And that's a cycle of every month?
No, that just happens once.
Yes.
Well, maybe the results start decreasing over time, and then you say, okay, let's retune things because this doesn't work. But if it works, and we're happy with those numbers, this is the last decrease here, we're pretty happy with that, and we don't touch it. You can try different hashing algorithms and see what happens. We did that. And that's why we choose differential hash instead of perceptual hash, because it gave us better results. So, prioritizing. You know which images will reach production. Now it's time to prioritize them. Really simple worker gets message, takes the status and says, from this image group, I want this image. And then it triggers to next step, generating. So we get the two groups that we found before. We get the images again. Now we need to pick the best image. We can say, this is the best image. It has tons of pixels. It has a nice histogram of colors. Maybe this image has 32 colors and we don't want to pick that. So we pick the best image according to our best knowledge. And then we pick the best order. How I want those images to be appearing in the gallery. Maybe I want the pool to be first or the bedroom to be second. Usually here what we do is we trust the order that the partner gives you. The partners usually tell you, hey, I sorted these images and I think this is the best order. They do the job for us, maybe we trust it. Otherwise, well, we try to apply some rules. But yeah. So what can go wrong doing that? Nothing, right? Yeah. Things go wrong. This was the best image, it had tons of pixels, nice resolution. So obviously you can do tons of interesting stuff here with machine learning. Maybe you could start features and say, oh, this has a bathroom. Let's put it way below please. Or maybe this is Thailand and you want to know that it has a front. So yes, that would be useful. Instead of doing that, because it's really expensive to that, we don't have that many resources yet, we implemented a tool so that we can manually go and prioritize those images. So if an issue like that pops up, we go there and we're able to fix it with some reasonable effort. I also remind you that we're hiring. And that's it. we just reached generation step. The generator gets a message from the queue again and do some work. So the work is putting an image into a bucket, and this bucket has the peculiarity that it's served through a CDN. We use CloudFront, full Amazon solution. And basically the final user is going to hit this. So the code looks kind of like this. We have all the 40 configurations that you saw are running different methods in the resizer, the generator, sorry. Resizing an image with PIL is really easy. You load the image with PIL and you say resize. And then you maybe want to choose the best filter for you. You use bilinear. You can use different filters. Depends on what you want between quality and time spent doing the resize. We make the image smaller. We want better contrast. You create an image enhanced object. You tell it how much contrast do you want. And that's it for the pipeline. The images are in production. So this is some numbers. This is the number that makes me happy. Images in production. And then you see how they are lost in each step. Because not all of them will reach production. There are duplicates. There are bad quality images. There are autos that don't even reach production because they are filtered on the data side. And this is an overview of what this looks like on Amazon. This is a deployment machine. We do our own DevOps. This is the API that we saw before. Everything behind the load balancer. We have the auto-scaling group of workers. So this is where the work really happens. And everything connects to that database. Who scales the workers? The API. The API receives a health check request, computes all the messages in the queue, how many messages we have in the queues, and says, hey, I need to do work. Let's just scale that up. And when everything finishes, you get the images in the bucket, served through the CDN. Final user, the apps, the website. So that's it. If you have any questions, I'll happily answer them.
I have a question. In the numbers of how many images you lost were lost in every step,
Yes.
the available row is all the images that you get, and then the 7 million in production are out of this.
Yes. This can only be one status. Yep.
When or how do you trigger the data release? So there is someone there, or it happens?
We do it manually.
You do it manually?
Yeah, we trigger the release. We try to do it once per week.
And someone just watches
Yeah,
images, or
you launch it. Yes. You just set it to a machine and you run the whole thing.
okay,
That's the legacy part.
yeah, it's fine.
Yeah. More questions?
Why do you use SQL Alchemy instead of the Django ORM?
Yeah. So, a workflow is a Django app or not? So we felt kind of it wasn't designed to. It made sense to us that if there is something that is not Django, why do we need to put Django there to access the database? Right? You can use an agnostic ORM and just include that as a dependency. Design decision. And we're happy with that. Maybe it was a bit weird if you are used to the Django ORM, but everything works. More questions? Nobody asked me why we didn't do that in real time, why we are scaling here. Why don't we have a service that scales that when a user hits the URL in flight? Nobody asked. So we don't do it, again, because of a design decision. There was no system in place in the company to do that job. And either you do that job properly or you focus on releasing images for the adults. And that's what the priority was. So it was really easy for us to add the next step of that pipeline and do this job ourselves. And again, we try to be efficient. If nothing changes, we are not going to generate images that are not used at the end. Although many of the images that you generate will never get to visit. That's the downside. But to be honest, storing things on S3 it's really cheap, so who cares? All the millions of images maybe are $50 a month, and they are terabytes too. More questions?
What are you using for selecting which is the image that you show for Intel as the primary one?
So when we prioritize, when we set the order, the first image in the list is going to be the hero image.
Exactly, there is no...
Yeah. If you are 0, then you're hero. More questions?
Have you tried using some kind of computer vision like OpenCV for data different things like a toilet or something like that?
Not yet.
I mean, it's in the backlog. I put it there. We add it in the backlog. Use image recognition to have better prioritization of images. Makes sense.
Once you have set up the order of the images, it's there forever, or you test if the switching them to out works better.
So I said that we manually prioritize the order. If something goes terribly bad, we go there and we change the order. But this order changes for the next release. So the current one is going to be with the bad order. It doesn't matter because we release weekly, which is not that frequent, but next release 1 week after, the toilet is going to be outside. That hero image.
Do you compare the results whenever you change the images? Like if there are more visits to that photo or whatever?
Our job, we are not even aware of the visits. Our job is to ensure that every hotel has images. We try to do that, yeah, so we don't do anything special according to the visits. Yeah? Your last chance? Okay.